In this third part, we're going to finish using the Euler form of complex numbers. So we had left in the last video of multiplying it. It also asks us to find the division. A divided by B is equal to 5e to the I pi over 2. And then we're going to divide that by 2e to the I pi over 4. This gives us 2.5 e to the I, and we have pi over 2 minus pi over 4 leads us to pi over 4. So it's also easy to divide complex number in the Euler's form. Divide magnitudes and subtract angles. One more thing before we leave the discussion of complex numbers. Idea of roots. You can use Euler's to find roots. Now let's show how this can be done. When you have a number, for instance, let's say that you're asked to find the square root of a number like 4. Now this is something we would appear not to need complex numbers, but it'll provide us a starting point. We have a vector whose length here is 4 units. You can think of it as tracing out, although I'm not very good at drawing a circle like that whose length is 4. And what this is saying is that 4 e to the I 0 was equal to some number a e to the I some angle times a e I to some angle. So 4 e to the I 0 was equal to a squared e to the I 2 times some angle. Now the thing about it is this isn't the only possibility. 4, yes, is at 0, but you could also go around any number of 2 pi. So we could also say plus n 2 pi, where n is equal to 0, 1, 2, any number of circles. Now looking at this, we see the first thing is that a squared, the length, is a number that you square to be 4, and the length has to be positive. So a is simply the positive root of 4, and that's 2. We also see that this angle, 2 theta, is equal to 0 plus n times 2 pi. So the angle is 0 divided by 2 plus n times 2 pi over 2. So theta is 0 plus n pi, where n is 0, 1, 2, 3, so forth. So we're going to be looking for the solution here is a circle that's only 2 units long, and the possibilities are an angle is 0, but also if n is 1, the possibility that you get pi is also allowed. So one answer is when the arrow's here. That's 2. Another possible answer, however, is when you go a distance pi around. That would be this way. That's 2 e to the I pi. Oh, but that's just minus 2. So there's the 2 roots. Now, I didn't need complex numbers to do that because I can do that with real ones, but this is the way it works for all numbers. You create a circle that's smaller by whatever the root is. Then you take your first root and you divide that pi up into the number of pieces of the root that you're taking. So if you're taking a square root, you chop that pi in two parts. So it gets one answer here and one answer 180 degrees out. If you're taking cube roots, you cut this pi into three parts. So one part would be here, one part would be there, one part would be down there. In that case, you'd have one real and two complex roots. Let me show you that by taking the cube root of 8. Find all roots for cube root of 8. So first thing we do, we got a circle. And its length, not a very good circle, I'll admit, not a great circle drawer. And its length is 8. So when we take the cube root of 8, the real number, the first root we're going to get, is going to be only 2. And we're going to have another circle. So one solution is 2e to the I 0, which is just 2. But back when we started this problem, we had 8e to the I 0 plus n 2 pi. And that was equal to some number cubed times e to the I 3 theta. So when we take this, we're going to divide this n over 2 pi by 3. So that means that instead of going all the way around when n is equal to 1, because we're now dividing it by 3, we're only going to go a third of the way. And so one of the answers is right here, where that is 2 pi over 3. So one root is 2. Another root is 2e to the I 2 pi over 3. And the last root is 2e to the I 4 pi over 3. 3 roots. 2 of them complex, 1 of them real. All I did was realize that the pi dropped down to a length of 2, and then the pi had to be chopped into 3 parts. Now, you can write that in terms of sines and cosines if you like. The first one is 2 plus no imaginary part. The second one, however, is 2 cosine 2 pi over 3 plus I times 2 sine of 2 pi over 3. Well, now this happens to be 1/2. And this happens to be the square root of 3 over 2. So this is 1 plus I times the square root of 3. The next one, if you go and do that work, you're going to find is equal, I'm sorry, this is minus 1 because that's minus 1/2. The next one will be minus 1 minus I square root of 3. So those are the 3 roots. This idea of complex numbers in Euler's is extremely powerful, but it takes some practice. In order to get you some practice, you might find a Shalm's outline book or find other math books that give you more practice in complex numbers. If you're going to go into the fields of engineering or you're already trying to major in those fields, it is important that you learn complex numbers. They're used extensively in the fields of engineering and science. If you're intending to be biology or something, then while it'll be useful for getting through your physics class, your use for it in other areas will not be as much. Okay, that finishes it for this video.